Welcoming you all to the 11th lecture of this electricity, and our topic today is net resistance in parallel combination. So for that I have taken R1, R2, R3 or the three different resistors combined in parallel combination with a battery of potential difference V volts as shown in the figure. So in parallel combination, when there are three different paths connecting three different resistors between 2 points, and those 2 points we connect a battery, then it's called parallel. So now I will say I1, I2 and I3 is the current across R1, R2, R3 respectively, and V is the potential drop across each resistor that you again know. Then current across I1 as per Ohm's law, it is equal to V by R1, current I2 is equal to V by R2, and current I3 is equal to V by R3. So if I will add up these three, that is simply I is equal to I1 plus I2 plus I3. Substituting the values of I becomes equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now if I will replace this diagram by its equivalent circuit diagram, while I replace this combination of resistor by a single resistor called as RP, that I will say if RP is the equivalent resistance of this combination, then according to Ohm's law for this equivalent circuit diagram, I is simply equal to V by RP. Now equating equation first and second, V by RP turns out to be V into 1 by R1 plus 1 by R2 plus 1 by R3, or 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is the reciprocal of net resistance in parallel combination is always equal to sum of reciprocals of individual resistances in parallel combination, which means if we will mathematically calculate that, it turns out that the net resistance in parallel combination is always less than the minimum resistance used in that combination.